Welcome to another session of Ebenezer Gate coaching classes. For the signal flow graph shown in the figure, the value of C of S by R of S is. Now, how many loops are there? This is one loop. This is another loop.
3 loops, sir.
This is third loop. Okay. This is H1, this is H2, this is H3. Any other loop is there?
No, sir.
Yeah, okay. How many forward paths?
One, sir.
Only one. And any loop not touching the forward path?
All are touching, sir.
So delta 1 is 1 minus 0. P1 is G1, G2, G3, G4. Okay. And what is L1? L1 minus G1, G2, H1. What is L2? Minus G3, G4, H2. What is L3? Minus G2, G3, H3. Okay. And which any two loops are not touching each other? L1 and L2. So L1, L2 is G1, G2, G3, G4, H1, H2. Okay. So it's very simple. What is delta? Delta is 1 minus the sum of single loops, that is 1 plus G1, G2, H1 plus G2, G3, H3 plus G3, G4, H2 plus G1, G2, G3, G4, H1, H2. So the answer is C of S by R of S is C of S by R of S is G1, G2, G3, G4 divided by 1 plus G1, G2, H1 plus G2, G3, H3 plus G3, G4, H2 plus G1, G2, G3, G4, H1, H2. Okay. So this is the answer. For the block diagram of the system shown below, determine C of S by R of S. Now, how will you do this? This is, you will have to remove this G of From here, you'll have to bring it here. Did we do this problem? Yesterday, did we do this problem?
Yes, sir. A similar diagram was.
Same. I think it's the same problem. So,
Sir, can you take analog, sir?
no, today we'll. I don't have
Yes,
the
sir.
PDF.
Okay, sir. I will again resend, sir.
If you want me to take another class, you tell me early, because let me see whether analog I can take. Okay.
Yes, sir.
The block diagram of the system is shown below. Determine the transfer function using Mason's gain formula. So you'll have to draw the signal flow graph. Okay. So now you have this summer and you have another summer here. The output of the summer is divided into two, so you can take it from here. Then here, this is G1. G2. Minus H1. Then G3. Minus H2. Minus H3. Okay. This is correct. So one summer, two summer, then G1. This output is going to the last one. Okay. Then you have G2. Then you have G3. G2's output, you are taking it here. Okay. And this here, you're giving a feedback here. Is this correct? Okay. Now, how many loops are there? This is one loop.
3 loops, sir.
This is one loop. This big loop is there. And this loop is also there, no?
Yes, sir. Yes, sir.
4 loops are there. Okay,
Yes, sir.
4 loops are there. And how many forward paths? How many forward paths?
So 1, 2, 2 forward paths, sir.
So P1 is G1, G2, G3. P2 is one. Okay. And any loop, what is L1? L1 is minus G1, G2, H1. L2 is minus G2, G3, H2. L3 is minus G1, G2, G3, H3. L4 is minus H3. Okay. And is there any L1? L1 is touching L2. L1 is touching L3. L1 is touching L4. L2 is touching L1. L2 is touching L3. L2 is touching L4. Okay. L3 is touching L3 and L4. L3 and L4 also are touching each other. So there are all loops are touching each other. So delta is only 1 minus sum of L1 plus L2 plus L3 plus L4. And delta 1, any loop not touching the forward path, this forward path, all loops are touching. And this forward path also 1, 2, 3, all loops are touching. So P1, delta 1 and delta 2 are 0. 1. Delta 1 is 1. Delta 2 is also 1. So it is G1, G2, G3 plus 1 divided by. So CFS by RFS is G1, G2, G3 plus 1 divided by one plus G1, G2, H1 plus G2, G3, H2 plus G1, G2, G3, H3 plus H4. So this is the answer to the problem.